Welcome to Sleepless History. This is a podcast designed to help you relax and drift off to sleep while learning about the fascinating details of historical events. Tonight, we will explore the history of Antarctic expeditions throughout recorded history. The story of humanity's exploration of Antarctica is one of courage, hardship, scientific discovery, and remarkable human endurance. So settle in, get comfortable, and let us begin our journey to the southernmost continent on Earth. If you enjoy tonight's story, please don't forget to like the video and subscribe. It helps the channel more than you may think. The history of Antarctic exploration begins not with the actual discovery of the continent itself, but with centuries of speculation and mythology. Ancient Greek philosophers theorized about a great southern land they called Terra Australis Incognita, the unknown southern land. They believed that such a landmass must exist to balance the known continents of the northern hemisphere. This was not based on any empirical evidence, but rather on a sense of cosmic symmetry. The idea persisted through the Middle Ages and into the Age of Exploration, driving many navigators to search for this mysterious southern continent. The first confirmed sighting of Antarctica is a matter of some historical debate. 3 separate expeditions claim to have seen the continent within days of each other in 1820. The first was led by a Russian naval officer named Fabian Gottlieb von Bellinghausen. On January 27, 1820, Bellinghausen's expedition, sailing aboard 2 ships named the Vostok and the Mirny, came within 20 miles of the Antarctic coast. His ships were part of a Russian circumnavigation of Antarctica, though ice conditions prevented him from actually landing on the continent. Just 3 days later, on January 30th, 1820, an Irish-born British naval officer named Edward Bransfield sighted the Antarctic peninsula from his ship, the HMS Williams. The third claimant to the first sighting was an American sealer named Nathaniel Palmer. Palmer was only 21 years old when, on November 17, 1820, he spotted the Antarctic peninsula while sailing in a small sloop named the Hero. Palmer was part of a sealing expedition from Stonington, Connecticut. These 3 sightings, all occurring within 10 months of each other, mark the beginning of confirmed human awareness of Antarctica as an actual place rather than a theoretical landmass. The first confirmed landing on continental Antarctica came the following year. On February 7, 1821, an American sealer named John Davis went ashore at Hughes Bay on the Antarctic Peninsula. Davis was the captain of the sealing ship Cecilia, and his landing was brief and purely practical. He was searching for seals, not conducting scientific research or claiming territory. In his ship's log, Davis wrote simply that he and his crew went ashore and stayed for about an hour. This understated entry marks one of the most significant moments in the history of human exploration. After these initial encounters, the next few decades saw sporadic visits to Antarctic waters, primarily by sealing and whaling vessels. These were commercial ventures, not scientific expeditions. The men who sailed these ships were hardened mariners seeking profit from seal pelts and whale oil. The conditions they faced were brutal. Antarctic waters are among the most dangerous in the world, with massive icebergs, sudden storms, and freezing temperatures. Many ships were lost, and many men died in these waters. yet the lure of profit was strong enough to keep them coming back. The first major scientific expedition to Antarctic waters was led by British naval officer James Clark Ross between 1839 and 1843. Ross was already an experienced polar explorer, having spent many years in the Arctic. His Antarctic expedition consisted of 2 ships, the HMS Erebus and the HMS Terra, both specially reinforced to withstand ice. These were the same ships that would later be lost in the Arctic during the ill-fated Franklin expedition, but in the Antarctic they performed admirably. Ross's expedition made several important discoveries. On January 11th, 1841, they crossed the Antarctic Circle and discovered the Ross Sea, which is now named after him. They also discovered Ross Island, the Ross Ice Shelf, and 2 volcanoes, which Ross named Mount Erebus and Mount Terra after his ships. Mount Erebus, at 12,448 feet, is the second highest volcano in Antarctica and the southernmost active volcano on Earth. The Ross Ice Shelf is a massive floating ice sheet, roughly the size of France, and its towering ice cliffs rise between 50 and 200 feet above the water. The Ross expedition also made important magnetic observations. One of the primary goals of the expedition was to locate the South Magnetic Pole. Although they were unable to reach it due to ice conditions, they determined its approximate location and made detailed measurements of the Earth's magnetic field in the southern polar regions. These observations were valuable contributions to the scientific understanding of geomagnetism. The crew faced enormous challenges during this expedition. Temperatures regularly dropped well below 0 degrees Fahrenheit. The ships became locked in ice for weeks at a time. Scurvy, a disease caused by vitamin C deficiency, was a constant threat. The crew's diet consisted primarily of salt pork, biscuits, and dried peas. Fresh food was virtually non-existent. Despite these hardships, Ross's leadership and the sturdy construction of his ships allowed the expedition to return to England with all crew members alive, a remarkable achievement for the era. Following Ross's expedition, there was a lull in Antarctic exploration for several decades. The focus of polar exploration shifted to the Arctic, where the search for the Northwest Passage and later the North Pole captured public imagination. However, in the late 19th century, interest in Antarctica revived. This renewed interest was partly driven by the International Geographical Congresses of 1895 and 1899, which called for renewed exploration of the Antarctic region for scientific purposes. This call led to what historians call the heroic age of Antarctic exploration, roughly spanning from 1897 to 1922. This period saw numerous expeditions from multiple countries driven by a combination of national pride, scientific curiosity, and personal ambition. The expeditions of this era were characterized by extreme hardship, remarkable feats of endurance, and sometimes tragedy. The Belgian Antarctic expedition of 1897 to 1899, led by Adrien de Gerlache aboard the ship Belgica, was the first expedition to overwinter in Antarctic waters. This was not intentional. The Belgica became trapped in pack ice in March 1898 and remained frozen in place for 13 months. The crew faced months of darkness, extreme cold, and isolation. Several men showed signs of serious psychological distress. 2 crew members died during the ordeal. Among the crew was a young Norwegian named Roald Amundsen, who was serving as first mate. This experience would prove invaluable to Amundsen's later Antarctic adventures. Also aboard was an American doctor named Frederick Cook, who would later claim to have reached the North Pole, though this claim is widely disputed. The expedition finally broke free of the ice in March 1899 and returned to Belgium. Despite the hardships, the expedition collected valuable scientific data and proved that humans could survive an Antarctic winter, albeit barely. The British National Antarctic Expedition of 1901 to 1904, led by Robert Falcon Scott aboard the ship Discovery, was the first major British expedition to Antarctica since James Clark Ross. Scott's expedition established a base on Ross Island and conducted extensive scientific research. The expedition included a young naval officer named Ernest Shackleton, who would later lead his own expeditions. In December 1902, Scott, Shackleton, and a third man named Edward Wilson attempted to reach the South Pole. They took dogs to pull their sledges, but the team had little experience with dog handling, and the animals performed poorly. The 3 men pushed south, hauling their sledges themselves when the dogs could no longer continue. They reached 82 degrees south, farther south than anyone had been before, but they were still more than 500 miles from the pole. Exhausted, suffering from scurvy, and with their food supplies running low, they turned back. The return journey was a nightmare. Shackleton became seriously ill, possibly with scurvy or a heart condition. Wilson and Scott had to help him walk. At times, they had to strap Shackleton to a sledge and drag him. All 3 men were frostbitten and emaciated when they finally reached their base. Despite the failure to reach the pole, the expedition was considered a success. They had set a new farthest south record, and the expedition's scientists had collected valuable data on Antarctic geology, biology, and meteorology. Ernest Shackleton returned to Antarctica in 1907, leading his own expedition. Shackleton's goal was to reach the South Pole. His expedition sailed south aboard the ship Nimrod, which was much smaller and older than Scott's Discovery. The Nimrod was only 136 feet long and had been built in 1867 as a sealing vessel. It was barely seaworthy, and the voyage south was rough. The ship leaked constantly, and the crew had to man the pumps day and night. Shackleton established a base at Cape Royds on Ross Island. In October 1908, Shackleton and 3 companions, Frank Wild, Eric Marshall, and Jameson Adams, set out for the pole. They took 4 ponies to pull the sledges. Shackleton had decided against using dogs, believing that ponies would be more effective. This proved to be a mistake. The ponies struggled in the deep snow and extreme cold. One by one, they had to be shot as they became too weak to continue. The meat was used to supplement the men's rations. The 4 men continued south, now pulling the sledges themselves. On December 26, 1908, they reached 88 degrees south, just 97 nautical miles from the pole. They had broken Scott's record by a huge margin. However, their food supplies were nearly exhausted. Shackleton made the difficult decision to turn back. In his diary, he wrote, "I thought you would rather have a live donkey than a dead lion." The return journey was desperate. The 4 men were starving. They had calculated their food rations based on reaching the pole, and now they had to stretch those rations even further. At one point, They were so weak that they could barely pull their sledges. They discarded everything they could to reduce weight, including scientific specimens they had carefully collected. When they finally reached their base camp in February 1909, they were mere shadows of themselves. Shackleton had lost 30 pounds, but they were alive, and they had set a new record for the closest approach to the South Pole. While Shackleton was setting this record in the Ross Sea region, another expedition was making history on the opposite side of the continent. The French Antarctic expedition of 1908 to 1910, led by Jean-Baptiste Charcot, explored the Antarctic peninsula. Charcot's expedition was primarily scientific in nature, focusing on mapping the coastline and collecting biological specimens. The expedition wintered aboard their ship, the Pourquoi Pas, which was specially built for polar conditions. The ship was equipped with a scientific laboratory, a dark room for photography, and even a small library. Charcot's men faced the same harsh conditions as other Antarctic explorers. They endured months of darkness during the Antarctic winter, temperatures that dropped to 40 below zero Fahrenheit, and the constant danger of their ship being crushed by ice. Despite these challenges, the expedition was remarkably productive. They mapped over 1,200 miles of coastline, discovered new islands, and collected thousands of biological and geological specimens. When they returned to France in 1910, they were hailed as heroes. Meanwhile, the race to reach the South Pole was intensifying. Robert Falcon Scott was preparing for a second Antarctic expedition. His goal this time was clear and simple: to be the first man to stand at the South Pole. Scott's Terra Nova expedition departed from England in June 1910. The expedition was well funded and elaborately planned. Scott brought motor sledges, ponies, dogs, and supplies for 3 years. The scientific program was ambitious, with specialists in geology, biology, and meteorology. Unknown to Scott, he had a rival. Roald Amundsen, the Norwegian explorer who had survived the Belgica expedition and had later navigated the Northwest Passage, was also planning an Antarctic expedition. Amundsen had originally planned to reach the North Pole, but when he learned that Robert Peary had already claimed that achievement in April 1909, Amundsen secretly changed his plans. He decided to race Scott to the South Pole. Amundsen's decision to compete with Scott was controversial. He kept his true intentions secret, even from most of his crew, until they were well at sea. When Scott learned that Amundsen was heading for the South Pole, he was surprised and dismayed, but determined to continue with his plans. The race was on. Amundsen's expedition arrived in Antarctica in January 1911 and established a base at the Bay of Whales on the Ross Ice Shelf. This location was about 60 miles closer to the pole than Scott's base at Cape Evans. Amundsen had chosen his location carefully based on his reading of earlier expeditions. Scott's expedition arrived shortly after and set up their base on Ross Island, using the same area where Scott had been during his discovery expedition. The two expeditions took very different approaches to reaching the pole. Scott relied primarily on man-hauling, where the explorers pulled their own sledges, supplemented by ponies and some dogs. Amundsen relied entirely on dog sledges. The Norwegians were expert dog handlers, having learned from the indigenous peoples of the Arctic. They brought 97 Greenland dogs and understood how to manage them in polar conditions. Scott, in contrast, had limited experience with dogs and believed that man-hauling was more noble and sporting, Amundsen and his team departed for the pole on October 20th, 1911. The Norwegian party consisted of 5 men: Amundsen, Olav Bjaaland, Helmer Hansen, Sverre Hassel, and Oscar Wisting. They took 4 sledges and 52 dogs. Scott and his larger party left about 2 weeks later on November 1st. Scott's initial party included 16 men, 10 ponies, 2 dog teams, and the motor sledges. The motor sledges broke down almost immediately, proving useless in the cold. The ponies struggled in the deep snow and had to be shot one by one as they became exhausted. Scott's party was reduced to man-hauling their heavy sledges across the ice. Each sledge weighed hundreds of pounds, and the men harnessed themselves to the sledges and pulled for 8 to 10 hours a day. It was brutally hard work. Amundsen's journey, while certainly difficult, went relatively smoothly. The dogs performed well, and the Norwegians made good progress. They had carefully planned their route and laid supply depots along the way. When the dogs were no longer needed, they were shot and fed to the remaining dogs, a practice that seems brutal by modern standards, but was essential for survival in an era before lightweight, high-energy foods. On December 14th, 1911, Amundsen and his 4 companions reached the South Pole. They spent 2 days at the pole, taking measurements to confirm their position and photographing the Norwegian flag they planted in the ice. Amundsen left a tent with a letter for Scott, asking Scott to deliver a message to the King of Norway in case Amundsen's party did not make it back. This letter would prove to be a devastating discovery for Scott. Amundsen's return journey was swift and efficient. The weather was generally favourable, and the dogs continued to perform well. The party reached their base at the Bay of Whales on January 25th, 1912, having travelled roughly 1,800 miles in 99 days. All 5 men and 11 dogs returned safely. It was a triumph of planning, skill, and efficiency. Scott's expedition faced a very different fate. The British party had been reduced to 5 men for the final push to the pole. Scott, Edward Wilson, Henry Bowers, Lawrence Oates, and Edgar Evans. They reached the pole on January 17th, 1912, 34 days after Amundsen. When they arrived, they found Amundsen's tent and the Norwegian flag. Scott wrote in his diary, "The worst has happened. All the daydreams must go. Great God, this is an awful place." The return journey was a disaster. The weather was unusually cold, even for Antarctica. Edgar Evans, who had suffered a serious head injury after falling into a crevasse, became increasingly confused and weak. He died on February 17th at the foot of the Beardmore Glacier. The remaining 4 men struggled on, but they were exhausted, frostbitten, and running low on food. Lawrence Oates was suffering terribly from frostbite. His feet were so badly frozen that he could barely walk. On March 17th, knowing that he was slowing the others down and reducing their chances of survival, Oates said, "I am just going outside, and maybe some time." He walked out of the tent into a blizzard and was never seen again. It was a deliberate act of self-sacrifice, though it ultimately proved futile. Scott, Wilson, and Bowers continued for a few more days, but they were too weak to go on. On March 21st or 22nd, they made their last camp just 11 miles from a supply depot that could have saved them. A blizzard trapped them in their tent. They had no fuel to melt snow for water, and their food was gone. They slowly froze to death. Scott spent his final days writing letters to the families of his companions and to the British public. His last diary entry, dated March 29th, reads in part, "We shall stick it out to the end, but we are getting weaker, of course, and the end cannot be far. It seems a pity, but I do not think I can write more." The bodies of Scott, Wilson, and Bowers were found by a search party 8 months later on November 12, 1912. They were still in their tent, with their diaries and letters beside them. The deaths of Scott and his companions were a national tragedy in Britain. Scott was remembered as a hero who had died in the pursuit of scientific knowledge and national glory. His last diary entries and letters, particularly his description of Oates' sacrifice, captured the public imagination. The tragedy overshadowed Amundsen's achievement. While Amundsen had won the race, Scott became the more celebrated figure, at least in Britain. This contrast between the efficient, successful Norwegian expedition and the tragic British expedition has fascinated historians ever since. While the race to the South Pole was unfolding, other expeditions were exploring different parts of Antarctica. The Australian Antarctic expedition of 1911 to 1914, led by Douglas Mawson, focused on scientific research rather than record-breaking journeys. Mawson's expedition explored the coast of Antarctica south of Australia, an area that was largely unknown. Mawson's expedition is remembered particularly for a harrowing survival story. In November 1912, Mawson set out on a sledging journey with 2 companions, Belgrave Ninnis and Xavier Mertz. On December 14th, Ninnis fell through a snow bridge into a deep crevasse. He disappeared into the darkness, and when Mawson and Mertz looked down, they could see no sign of him. The crevasse was at least 150 feet deep. Ninnis had taken with him one of the dog teams and the sledge carrying most of the food supplies. Mawson and Mertz were now 300 miles from base with only 10 days of food. They began a desperate race back. To survive, they killed and ate their remaining dogs one by one. Unknown to them, husky liver contains toxic levels of vitamin A. Both men began to suffer from hypervitaminosis A, which causes severe illness. Mertz's condition deteriorated rapidly. He became delirious and refused to eat. On January 7th, 1913, Mertz died. Mawson continued alone. He was suffering from starvation, frostbite, and vitamin A poisoning. The skin was peeling off his body in sheets. His feet were so damaged that the soles came off completely, and he had to bandage them back in place. At one point, he fell into a crevasse and was saved only by the sledge harness, which caught on the ice above. He hung there, contemplating simply cutting the rope and ending his suffering. Instead, he slowly pulled himself up, rested, and continued. Mawson reached a supply depot in early February and found a note informing him that the relief ship had left just hours earlier. He had missed rescue by a matter of hours. Mawson had no choice but to make his way back to the main base, which he reached on February 8th. He was emaciated and barely recognizable. The relief ship had departed again, and Mawson had to spend another entire winter in Antarctica before he could return home. Despite this incredible ordeal, Mawson lived to the age of 76 and continued to contribute to Antarctic science for decades. The heroic age of Antarctic exploration also included Ernest Shackleton's most famous expedition, the Imperial Trans-Antarctic Expedition of 1914 to 1917. Shackleton's goal was to cross the entire Antarctic continent, a feat that had never been attempted. The plan was for Shackleton's party to land on one side of the continent, cross to the South Pole, and continue to the opposite coast where a support party would have laid supply depots. Shackleton's ship, the Endurance, departed from England in August 1914, just as World War I was beginning. The Endurance sailed south and entered the Weddell Sea in December. In January 1915, the ship became trapped in pack ice. Shackleton and his crew hoped the ice would break up with the coming spring, but instead the ice tightened its grip. The Endurance drifted with the ice for months, slowly being crushed. On October 27th, 1915, the pressure of the ice finally broke the ship's hull. The Endurance sank on November 21st. Shackleton and his 27 crew members were now stranded on the ice more than 1,200 miles from the nearest civilization. They had 3 small lifeboats, limited supplies, and the clothes on their backs. The temperature was well below zero. The 28 men camped on the ice for months as it drifted slowly north. They lived in tents, hunted seals and penguins for food, and waited for the ice to break up. Shackleton maintained strict discipline and morale. He organised games and competitions to keep the men occupied. On April 9th, 1916, the ice finally broke apart enough for them to launch the lifeboats. The men spent 7 brutal days in the open boats, rowing through towering waves and dodging icebergs. They were soaked with freezing seawater, and several men showed signs of hypothermia and frostbite. On April 14th, they landed on Elephant Island, a desolate, rocky island at the edge of the Antarctic Peninsula. It was the first time they had stood on solid ground in 497 days. Elephant Island was uninhabited and far from any shipping routes. No rescue would come to them there. Shackleton decided on a desperate plan. He would take 5 men in one of the lifeboats and sail 800 miles across the Southern Ocean to South Georgia Island, where there was a whaling station. It was one of the most dangerous sea journeys ever attempted. The Southern Ocean is notorious for its massive waves and violent storms. Shackleton and his 5 companions, Frank Worsley, Tom Crean, Timothy McCarthy, John Vincent, and Harry McNish, set sail on April 24th in the James Caird, a 22-foot lifeboat. The journey took 17 days. They navigated by sextant, taking readings when the sun briefly appeared through the clouds. Most of the time, they were drenched with seawater. They had to constantly bail water to keep the boat from sinking. They suffered from seasickness, dehydration, and exhaustion. On May 10th, 1916, they reached South Georgia Island, but they landed on the wrong side of the island, away from the whaling stations. A cliff-lined coast and treacherous waters prevented them from sailing around the island. Shackleton decided they would have to cross the island on foot. This was no small task. South Georgia Island is mountainous, covered with glaciers, and had never been crossed before. They had no proper climbing equipment, no map, and they were already exhausted. Shackleton, Worsley, and Crean set out on May 19th, leaving the other 3 men behind. They climbed mountains and crossed glaciers, often having to backtrack when they encountered impassable terrain. At one point, they slid down a steep, icy slope in the dark, not knowing what was at the bottom. They could have been killed, but they landed safely in deep snow. After 36 hours of non-stop walking, they heard a sound they had not heard in over a year. A factory whistle from the whaling station. They had made it. The whalers at Stromness station were shocked to see 3 ragged, emaciated men stumble into their camp. Shackleton immediately began organising a rescue for the men left behind on Elephant Island. However, the Antarctic winter was setting in, and ice conditions made it impossible for a ship to reach the island. Shackleton tried 4 times to reach Elephant Island, using different ships. Each time, pack ice forced him to turn back. Finally, on August 30th, 1916, on his 4th attempt and aboard a Chilean steam tug called the Yelko, Shackleton reached Elephant Island. The 22 men who had been waiting there for more than 4 months were all alive. Frank Wild, who had been in charge during Shackleton's absence, had maintained discipline and morale. Every morning, he had the men roll up their sleeping bags saying, "Shackleton will come today." And finally, Shackleton did come. Not a single man from the Endurance expedition was lost. It remains one of the greatest survival stories in the history of exploration. The period between the 2 world wars saw a shift in Antarctic exploration. The focus moved from individual heroic journeys to larger, more systematic scientific programs. Technology began to play a larger role. The first airplane flight in Antarctica took place in 1928. An Australian pilot named Hubert Wilkins and his American co-pilot Carl Ben Eielson flew over the Antarctic Peninsula, demonstrating that aircraft could be used for polar exploration. The American explorer Richard Byrd led several major expeditions to Antarctica between 1928 and 1956. Byrd was a naval aviator who had flown over the North Pole in 1926, though this claim is now disputed. His first Antarctic expedition from 1928 to 1930 established a base called Little America on the Ross Ice Shelf. On November 29, 1929, Byrd and his crew made the first airplane flight over the South Pole. The flight took 19 hours round trip. Byrd's expeditions were notable for their use of modern technology. They employed radio communications, aerial photography, and tracked vehicles. Byrd also spent nearly 5 months alone at an advanced weather station during the winter of 1934, an experience he later described in his book Alone. He nearly died from carbon monoxide poisoning from a faulty stove, but was eventually rescued by his men. During World War II, Antarctic exploration was largely suspended as nations focused on the war effort. However, the strategic importance of Antarctica was not forgotten. After the war, several nations established territorial claims in Antarctica, and there were concerns that the continent could become a site of international conflict. These concerns led to the negotiation of the Antarctic Treaty, which was signed by 12 nations in 1959 and came into force in 1961. The treaty designated Antarctica as a scientific preserve, established freedom of scientific investigation, and banned military activity on the continent. It also froze all territorial claims, neither recognizing them nor denying them. The Antarctic Treaty has been remarkably successful and has been signed by 54 nations as of the early 21st century. The International Geophysical Year of 1957 to 1958 saw a massive increase in Antarctic research. 12 nations established over 60 research stations across Antarctica. One of the most significant expeditions of this period was the Commonwealth Trans-Antarctic Expedition of 1955 to 1958, led by British explorer Vivian Fuchs. This expedition finally achieved what Shackleton had attempted, a crossing of the entire Antarctic continent. Fuchs's expedition departed from the Weddell Sea coast on November 24, 1957. The party used tracked vehicles called snowcats as well as dog sledges. They crossed the continent via the South Pole, covering 2,158 miles in 99 days. A support party led by Edmund Hillary, the New Zealand mountaineer who had climbed Mount Everest in 1953, laid supply depots from the Ross Sea side and reached the South Pole ahead of Fuchs. This was the first overland crossing of Antarctica, accomplished 43 years after Shackleton's attempt. The expedition relied heavily on mechanized transport, marking a departure from the man-hauling and dog sledges of the heroic age. The success of Fuchs's expedition demonstrated that with modern equipment, humans could traverse even the most hostile environments on Earth. The latter half of the 20th century saw Antarctica become primarily a site of scientific research rather than exploration for its own sake. Permanent research stations were established by many nations. The United States operates several stations, including McMurdo Station, which is the largest settlement in Antarctica, with a summer population that can exceed 1,000 people. The Amundsen Scott South Pole Station sits directly on the geographic South Pole and is permanently staffed. Research in Antarctica covers many fields. Glaciologists study the ice sheets to understand climate change. The Antarctic ice core projects have extracted ice from depths of over 2 miles, providing a record of Earth's climate going back hundreds of thousands of years. Marine biologists study the unique ecosystems of Antarctic waters, including the tiny krill that form the base of the food chain. Astronomers take advantage of the clear, dry air and long polar nights to observe the stars. Medical researchers study how the human body adapts to extreme cold and isolation. One of the most important scientific discoveries in Antarctica came in 1985 when British Antarctic Survey scientists discovered a hole in the ozone layer above Antarctica. This discovery led to the Montreal Protocol of 1987, an international agreement to phase out the production of chlorofluorocarbons and other ozone-depleting substances. The Antarctic ozone hole is now slowly recovering, demonstrating that international cooperation can address global environmental problems. Despite the focus on science, the spirit of adventure has not disappeared from Antarctica. In 1989, a 6-person international expedition successfully crossed Antarctica using only dog sledges, a journey of nearly 4,000 miles that took 7 months. In 1993, Ranulph Fiennes and Mike Stroud completed the first unsupported crossing of Antarctica, pulling their own sledges without resupply, covering 1,350 miles in 95 days. In recent decades, there has been an increase in commercial tourism to Antarctica. Cruise ships now regularly visit the Antarctic Peninsula during the summer months, bringing thousands of tourists to see the penguins, seals, and spectacular ice formations. These tourism operations are regulated by the Antarctic Treaty System to minimize environmental impact, but they represent a dramatic change from the era when only a handful of explorers ever set foot on the continent. Climate change is now the most pressing issue facing Antarctica. The Antarctic Peninsula is one of the fastest warming places on Earth. Ice shelves are collapsing and glaciers are retreating. The loss of Antarctic ice contributes to sea level rise, which threatens coastal communities around the world. Scientists continue to study these changes using satellites, automated weather stations, and field research. In recent years, there have been several significant developments in our understanding of Antarctica. In 2007, hidden lakes were discovered beneath the Antarctic ice sheet. These subglacial lakes, of which over 400 are now known, have been isolated from the surface for millions of years. The largest is Lake Vostok, which is roughly the size of Lake Ontario. Scientists are interested in these lakes because they may harbour unique life forms that have evolved in complete isolation. Drilling projects have reached some of these lakes. In 2013, Russian scientists drilled through 2.5 miles of ice to reach Lake Vostok. The samples they retrieved are being studied for signs of microbial life. Understanding life in these extreme environments has implications for astrobiology, the search for life on other planets. If life can exist in the dark, cold waters beneath Antarctic ice, perhaps it could also exist in similar environments on Jupiter's moon Europa or Saturn's moon Enceladus. The exploration of Antarctica's interior continues even today. In 2018 to 2019, an international team used ice-penetrating radar to map the transantarctic mountains, revealing features of the bedrock that lies beneath miles of ice. These surveys help scientists understand the structure of the continent and how the ice sheet might respond to climate change. One of the most challenging aspects of Antarctic research is the sheer remoteness and harshness of the environment. Researchers must be prepared for extreme cold, isolation, and the psychological challenges of spending months in darkness during the polar winter. The medical evacuation of sick or injured personnel is extremely difficult, especially during winter when flights are nearly impossible. This has led to several dramatic rescue missions over the years. In 1999, Dr. Jerry Nielsen, a physician working at the South Pole Station, discovered a lump in her breast. It was midwinter and no flights could reach the pole. She performed a biopsy on herself and began chemotherapy using drugs that were airdropped to the station. When conditions allowed, she was evacuated in October, a daring midwinter flight that required exceptional piloting skill. She survived and later wrote a book about her experience. Modern Antarctic expeditions still face many of the same challenges that confronted Shackleton and Scott. The cold can freeze exposed skin in seconds. Whiteout conditions can make it impossible to see more than a few feet. Crevasses hidden beneath snow bridges remain a constant danger. Despite all our technology, Antarctica remains a place where human life exists only with great effort and constant vigilance. The logistical challenges of supporting research in Antarctica are immense. Everything must be imported: food, fuel, building materials, scientific equipment. The main supply route to Antarctica is by ship during the brief Antarctic summer. These ships must break through sea ice to reach research stations. The journey from the nearest port can take weeks. In winter, many stations are completely cut off from the outside world. The cost of operating in Antarctica is enormous. It can cost tens of thousands of dollars just to transport a single researcher to and from the continent. Building and maintaining research stations in such extreme conditions is expensive, yet dozens of nations continue to support Antarctic research because the scientific knowledge gained is invaluable for understanding our planet. Antarctica plays a crucial role in Earth's climate system. The Antarctic ice sheet contains about 61% of all fresh water on Earth. If it were to melt completely, sea levels would rise by about 200 feet. While complete melting is not expected in the foreseeable future, even a partial loss of Antarctic ice would have catastrophic consequences for coastal cities around the world. The study of ancient ice cores has revolutionized our understanding of Earth's climate history. By analyzing air bubbles trapped in ice that fell as snow hundreds of thousands of years ago, scientists can determine the composition of the atmosphere in the distant past. This research has shown that current levels of carbon dioxide in the atmosphere are higher than at any time in at least the last 800,000 years. Antarctica is also home to unique life forms that have adapted to survive in extreme conditions. Emperor penguins breed on the sea ice during the Antarctic winter, enduring temperatures that can drop to minus 70 degrees Fahrenheit. The males incubate the eggs on their feet under a fold of skin while the females are away feeding. They huddle together for warmth, taking turns being on the outside of the huddle where it is coldest. This is one of the most remarkable examples of parental care in the animal kingdom. The waters around Antarctica are among the most productive in the world. Upwelling currents bring nutrients from the deep ocean to the surface, supporting vast blooms of phytoplankton. These microscopic plants are eaten by krill, small shrimp-like creatures that occur in enormous swarms. The krill are in turn eaten by whales, seals, penguins, and many species of fish. This food web supports some of the largest populations of marine mammals on Earth. However, these ecosystems are threatened by climate change and fishing. Krill populations have declined in some areas, possibly due to the reduction in sea ice, which provides important habitat for juvenile krill. Commercial fishing for krill and toothfish has increased in recent decades. While these fisheries are regulated by the Commission for the Conservation of Antarctic Marine Living Resources, there are concerns about illegal, unreported, and unregulated fishing. The political status of Antarctica remains unique in international law. The Antarctic Treaty System has successfully prevented military conflict and nuclear testing on the continent. The Protocol on Environmental Protection to the Antarctic Treaty, which came into force in 1998, designates Antarctica as a natural reserve devoted to peace and science. It prohibits mineral mining and establishes strict environmental standards for all activities. 7 nations maintain territorial claims in Antarctica: Argentina, Australia, Chile, France, New Zealand, Norway, and the United Kingdom. Some of these claims overlap. The United States and Russia have reserved the right to make claims, but have not done so. Under the Antarctic Treaty, these claims are neither recognized nor disputed, and all parties agree to the freedom of scientific investigation across the entire continent. As we look to the future, Antarctica will continue to be a crucial site for scientific research. Understanding how the Antarctic ice sheet responds to global warming is essential for predicting future sea level rise. Long-term monitoring of Antarctic ecosystems will help us understand the impacts of climate change on biodiversity. And the study of extreme environments in Antarctica will continue to push the boundaries of what we know about life on Earth and possibly beyond. The history of Antarctic exploration is a testament to human curiosity, courage, and perseverance. From the first sightings in 1820 to the sophisticated research programs of today, Antarctica has challenged explorers to overcome seemingly impossible obstacles. The early explorers faced these challenges with primitive equipment and limited knowledge, relying on courage, ingenuity, and sheer determination. The stories of these expeditions continue to fascinate us because they represent humanity at its most adventurous and most vulnerable. The triumph of Amundsen, the tragedy of Scott, the survival of Shackleton, and the ordeal of Mawson are more than just historical events. They are profound human dramas that reveal both the best and worst of human nature. These explorers expanded the boundaries of human knowledge and human capability. They mapped an unknown continent, discovered new species, and gathered data that continues to inform scientific research today. They also paid a heavy price. Many died in pursuit of their goals. Many more suffered terribly from cold, hunger, disease, and injury. Their sacrifices remind us that exploration is not just about glory and achievement, but also about risk and loss. The transition from the heroic age to the modern era of Antarctic science represents a fundamental change in how we approach polar exploration. We no longer send men to pull sledges across the ice for months on end, though some adventurers still choose to make such journeys. Instead, we use airplanes, helicopters, and sophisticated vehicles. We have satellites to track weather and ice conditions. We have heated buildings with electricity and communication systems that keep researchers connected to the rest of the world. Yet, despite all this technology, Antarctica remains a dangerous and challenging environment. The cold is still deadly, the isolation is still profound, the weather can still trap people for weeks or months. The research conducted in Antarctica still requires dedication, expertise, and a willingness to endure hardship. The international cooperation that characterizes modern Antarctic research is one of the great success stories of the 20th century. During the Cold War, when the United States and Soviet Union were adversaries almost everywhere else in the world, they cooperated in Antarctica. Scientists from these countries worked together, shared data, and maintained friendly relations at research stations. This cooperation has continued and expanded in the decades since. Antarctica reminds us that there are still places on Earth that are wild, dangerous, and largely untouched by human civilization. It is a continent where nature still dominates, where the wind and cold and ice are more powerful than any human technology. In an age when humans have transformed most of the planet, Antarctica stands as a reminder of what Earth was like before our species began to reshape it. The Antarctic Treaty, by preserving Antarctica for peaceful purposes and scientific research, represents a vision of international cooperation that many hope could be extended to other areas. If nations can agree to share Antarctica and work together for scientific advancement, perhaps similar agreements can be reached for other parts of the world or even for outer space. As climate change accelerates, Antarctica will play an increasingly important role in Earth's future. The decisions we make in the coming decades about greenhouse gas emissions will largely determine how much Antarctic ice melts and how much sea levels rise. The data gathered by scientists working in Antarctica is crucial for understanding these changes and planning for the future. The study of climate change is perhaps the most important scientific work being conducted in Antarctica today. Ice cores, satellite measurements, and field observations are all contributing to our understanding of how Earth's climate is changing and what the consequences might be. This research has profound implications, not just for science, but for policy, economics, and the future of human civilization. Looking back at the history of Antarctic exploration, we can see how much has changed in just over 200 years. In 1820, Antarctica was a mysterious, unknown land. Today, we have detailed maps of the continent, including the topography of the bedrock beneath the ice. We understand the basic physics of ice sheets, the biology of Antarctic organisms, and the role Antarctica plays in the global climate system. Yet, there is still much we do not know. The behavior of Antarctic ice shelves under continued warming is not fully understood. The ecosystems beneath the ice remain largely unexplored. The full extent of mineral resources in Antarctica is unknown, and under the Antarctic Treaty, they must remain unexploited. Every year, scientists working in Antarctica make new discoveries that change our understanding of this frozen continent. The human stories of Antarctic exploration continue to inspire new generations. The bravery of Scott and his companions, the leadership of Shackleton, the efficiency of Amundsen, and the endurance of Mawson are lessons in courage, determination, and the human spirit. These stories remind us that exploration is not just about reaching a destination, but about the journey itself and what we learn along the way. Modern adventurers continue to test themselves against Antarctica. Some ski to the South Pole, some attempt to cross the continent, some climb the highest peaks. These journeys, while supported by modern equipment and communications, still require extraordinary physical and mental strength. They keep alive the tradition of individual achievement that characterized the heroic age. The future of Antarctica is uncertain. Climate models predict that warming will continue and the rate of ice loss may accelerate. Some scientists warn that we may be approaching tipping points beyond which changes become irreversible. Others are more optimistic, believing that if we act quickly enough, we can limit the damage. What is certain is that Antarctica will continue to be a focus of scientific research and international concern for decades to come. The Antarctic Treaty System faces new challenges as well. As technology advances, the possibility of mining Antarctic minerals may become more attractive to some nations. The pressure to exploit Antarctic resources could test the commitment to keeping Antarctica as a peaceful scientific preserve. So far, the treaty has held, but the future is not guaranteed. Tourism to Antarctica is also raising new questions. While tourism can help people appreciate the beauty and importance of Antarctica, it also brings risks of environmental damage and accidents. Cruise ships carrying hundreds of passengers require fuel, produce waste, and can disturb wildlife. Regulations are in place to minimize these impacts, but as tourism grows, these concerns will become more pressing. One of the remarkable aspects of Antarctica is its effect on the people who visit. Many who have worked in Antarctica describe it as a life-changing experience. The beauty of the landscape, the stark simplicity of life in such an extreme environment, and the sense of being part of something larger than oneself all contribute to this effect. Antarctica has a way of putting human concerns into perspective. The darkness of the polar winter and the isolation of Antarctic stations can be psychologically challenging. People living through the winter months experience sensory deprivation, disrupted sleep patterns, and the stress of living in close quarters with a small group for extended periods. Research on Antarctic winter cruise has contributed to our understanding of how humans might cope with long-duration spaceflight, where similar conditions would apply. The practical challenges of daily life in Antarctica are considerable. Water must be melted from snow or ice. Buildings must be designed to withstand winds that can exceed 100 miles per hour. Equipment that works perfectly in temperate climates often fails in the cold. Batteries lose their charge, metal becomes brittle, and lubricants freeze. Every task takes longer and requires more effort in the extreme cold. Despite these challenges, or perhaps because of them, there is a strong sense of camaraderie among those who work in Antarctica. The shared experience of living in such an extreme environment creates bonds that last a lifetime. Many people who have worked in Antarctica return again and again, drawn by the unique combination of scientific opportunity, natural beauty, and personal challenge. The legacy of the early Antarctic explorers lives on in the names scattered across the map of Antarctica. The Ross Sea and Ross Island, the Shackleton Range, the Amundsen Sea, Scott Base, Mawson Station, and countless other features bear the names of those who explored the continent. These names are not just geographic labels, but reminders of the human history of Antarctic exploration. The scientific legacy is equally important. The expeditions of the heroic age, despite their focus on reaching the pole, also conducted important scientific work. They collected geological and biological specimens, made meteorological observations, and mapped unknown coastlines. This tradition of combining exploration with science continues today, with researchers pushing into the most remote parts of Antarctica to answer fundamental questions about our planet. As we conclude this exploration of Antarctic expedition history, it is worth reflecting on what draws humans to such places. Antarctica offers no economic rewards beyond fishing and tourism. It is not suitable for human habitation without massive technological support. Yet people continue to go there, to work there, and sometimes to die there. What is it about Antarctica that exerts such a powerful pull on the human imagination? Perhaps it is the challenge itself. Antarctica represents one of the last great challenges on Earth, a place where nature still sets the rules and humans must adapt or perish. In a world that often feels completely mapped and explored, Antarctica remains a place of genuine wilderness and danger. For some, this is irresistible. Or perhaps it is the purity of the place. Antarctica is the cleanest continent on Earth, largely untouched by pollution and human development. The air is so clear that visibility can extend for miles. The ice is ancient and pristine. For scientists, it offers a natural laboratory for studying processes that would be difficult or impossible to study elsewhere. Or perhaps it is simply the beauty. Antarctica is stunningly beautiful in a stark, minimalist way. The ice sculptures created by wind and weather, the play of light on ice and snow, the aurora australis dancing in the polar night sky, and the abundant wildlife all contribute to an aesthetic experience unlike anywhere else on Earth. Whatever the reason, Antarctica continues to capture human imagination more than 200 years after its discovery. The stories of Antarctic exploration, from the first sightings to the present day, are stories of human ambition, courage, suffering, and achievement. They remind us of our capacity for both great accomplishments and terrible mistakes. The exploration of Antarctica is far from over. Every year, scientists make new discoveries. Every season, adventurers set new records. The continent continues to challenge us, to teach us, and to inspire us. As long as humans are curious about the world around us, as long as we are willing to endure hardship in pursuit of knowledge, Antarctica will remain a focal point of exploration and research. In the quiet hours of the polar night, under skies blazing with stars and curtains of aurora, it is easy to understand why Antarctica has such power over those who visit. It is a place that strips away the unnecessary, that forces us to confront the essential questions of survival and purpose. It is a place where the forces of nature are clearly visible and undeniable. The history of Antarctic expeditions is ultimately a human history. It is about people pushing the limits of endurance, about nations competing and cooperating, about scientists seeking knowledge, and about adventurers seeking glory. It is about success and failure, life and death, triumph and tragedy. It is a history that continues to unfold, as each new expedition adds its chapter to the long story of humanity's relationship with the frozen continent at the bottom of the world. And now, as we conclude this journey through the history of Antarctic exploration, we hope that these stories of courage, endurance, and discovery have provided you with a deeper appreciation for this remarkable continent and the remarkable people who have explored it. May these tales accompany you gently into restful sleep, with dreams perhaps of ice and snow, of brave explorers facing impossible odds, and of a continent at the end of the earth that continues to captivate and challenge humanity. The German Antarctic expedition of 1901 to 1903, led by Erich von Drygalski aboard the ship Gauss, made significant contributions to Antarctic science, though it is less well known than some of the British expeditions of the same era. The Gauss became trapped in ice in February 1902 and remained frozen in place for 14 months. Unable to free the ship, Drygalski and his crew used this time productively, conducting extensive scientific observations. The expedition discovered new land, which they named Kaiser Wilhelm, the Second Land. They also conducted the first balloon ascent in Antarctica, reaching an altitude of 1,600 feet, which allowed them to photograph the surrounding ice fields from above. This was a remarkable achievement using the primitive balloon technology of the time. The hydrogen needed to inflate the balloon had to be generated on site using chemical reactions, a dangerous process in the extreme cold. The scientific work conducted by the Gauss expedition was comprehensive. They made detailed meteorological observations throughout their enforced stay, recording temperature, wind speed, and barometric pressure every few hours. They studied the aurora australis, making sketches and descriptions of the phenomenon. They collected geological samples and studied the magnetism of the region. When the ship finally broke free in February 1903, they returned to Germany with a wealth of scientific data. The Japanese Antarctic expedition of 1910 to 1912, led by Lieutenant Nobu Shiraze, is another lesser-known but significant expedition from the Heroic Age. Japan was a relative newcomer to Antarctic exploration, and Shiraze's expedition faced considerable skepticism, both at home and from other nations. The expedition was poorly funded and departed late in the season, arriving in Antarctica in January 1912. Despite these disadvantages, the Japanese team achieved notable success. They landed on the Ross Ice Shelf and made a dash toward the South Pole, though they knew they could not reach it. They achieved 80 degrees south before turning back, a creditable performance given their late start and limited resources. They collected geological and biological specimens and made meteorological observations. The expedition also explored King Edward VII Land, an area on the Ross Sea coast that had been seen but not thoroughly explored by earlier expeditions. The Scottish National Antarctic Expedition of 1902 to 1904, led by William Spears Bruce, focused on the Weddell Sea region. Bruce was a scientist rather than a naval officer, and his expedition placed a strong emphasis on scientific research. The expedition ship, the Scotia, was a former Norwegian whaling vessel that had been specially reinforced for ice work. The Scotia expedition discovered Coates Land on the Weddell Sea coast and conducted extensive oceanographic work. They collected samples from the seafloor and studied ocean currents and temperatures. They also established a meteorological station on Laurie Island in the South Orkney Islands, which was later taken over by the Argentine government and continues to operate to this day, making it one of the longest-running meteorological stations in the Antarctic region. Bruce's expedition demonstrated that scientific exploration could be conducted successfully without the competitive race mentality that characterized some other expeditions. The Scotia returned to Scotland with collections of geological, biological, and oceanographic specimens that formed the basis for years of scientific research. Bruce himself continued to advocate for further Antarctic research until his death in 1921. The Swedish Antarctic expedition of 1901 to 1904, led by Otto Nordenskjöld, faced one of the most dramatic survival situations of the heroic age. The expedition's ship, the Antarctic, deposited Nordenskjöld and 5 companions at Snow Hill Island off the Antarctic Peninsula in February 1902, with plans to return and pick them up the following summer. However, when the Antarctic attempted to return in February 1903, it became trapped in ice and was eventually crushed and sank. The ship's crew, under Captain Carl Anton Larsen, managed to escape to Paulet Island with 3 small boats and limited supplies. Meanwhile, a 3-man sledging party that had been dropped off earlier became separated and had to winter in a stone hut they built on another island. The 3 groups survived the winter of 1903 separately, not knowing if the others had survived. In the spring of 1903, one of Nordenskjöld's companions, Jose Maria Sobral, made a solitary journey and discovered the shipwrecked crew. Eventually, all 3 groups were reunited and rescued by an Argentine relief ship in November 1903. All members of the expedition survived this remarkable ordeal, and they brought back valuable scientific data and specimens. The French Antarctic expedition of 1903 to 1905, led by Jean-Baptiste Charcot, was the first of 2 expeditions Charcot would lead to Antarctica. This expedition explored the western coast of the Antarctic Peninsula in the ship Francais. Charcot was a wealthy physician who financed much of the expedition from his own resources. The expedition was characterized by thorough scientific work and good leadership. The Francais expedition discovered new islands and channels, conducted bathymetric surveys, and collected numerous specimens. Charcot established a winter base on Booth Island, where the crew conducted scientific observations throughout the winter of 1904. The expedition demonstrated that smaller, well-organized expeditions could make significant contributions to Antarctic knowledge without the massive funding and publicity of some larger expeditions. The period leading up to World War I saw several other expeditions to Antarctica. The Australasian Antarctic Expedition of 1911 to 1914, led by Douglas Mawson, which we discussed earlier, was part of this wave of exploration. Another significant expedition was the German expedition led by Wilhelm Filchner in 1911 to 1913. Filchner's expedition aboard the Deutschland aimed to cross Antarctica from the Weddell Sea to the Ross Sea, predating Shackleton's similar plan by several years. The Deutschland entered the Weddell Sea and discovered the Filchner ice shelf, a massive floating ice sheet. However, like many expeditions in the Weddell Sea, the ship became trapped in ice and drifted for 9 months before breaking free. The plan to cross Antarctica had to be abandoned, but the expedition conducted valuable oceanographic and meteorological research. The outbreak of World War I in August 1914 had a profound impact on Antarctic exploration. Shackleton's Imperial Trans-Antarctic Expedition departed just as the war began. When Shackleton offered to cancel the expedition and place his ship and men at the service of the British government, the First Lord of the Admiralty, Winston Churchill, sent a one-word telegram in reply: "Proceed." The war years from 1914 to 1918 saw virtually no exploration of Antarctica. The ships, resources, and manpower that might have been devoted to polar exploration were needed for the war effort. Many men who had been on Antarctic expeditions served in the military during the war, and some did not survive. The focus of the world was on the terrible conflict in Europe, and Antarctica was largely forgotten. After the war, there was renewed interest in Antarctica, but the character of exploration was changing. The heroic age, with its emphasis on individual heroism and man-hauling sledges across the ice, was giving way to a new era of mechanized exploration and systematic scientific research. This transition was not immediate, and there were still expeditions in the 1920s and early 1930s that followed the old model, but the trend was clear. The British Antarctic Expedition of 1920 to 1922, known as the Quest Expedition, was Ernest Shackleton's final Antarctic venture. Shackleton had survived the war years and was eager to return to the south. The Quest Expedition had ambitious goals, including a circumnavigation of Antarctica and exploration of unknown coastlines. However, the expedition was poorly funded, and the Quest itself was a small, aging ship that was barely suitable for Antarctic waters. The expedition departed England in September 1921. Shackleton's health had been declining for some time, though he tried to hide this from his crew and sponsors. On January 5, 1922, while the Quest was anchored at South Georgia Island, Shackleton suffered a fatal heart attack. He was 47 years old. He was buried at South Georgia at the request of his wife, rather than being brought back to England. His grave overlooks the waters he had crossed in the James Caird 6 years earlier. The loss of Shackleton marked the end of an era. He had been one of the most prominent figures in Antarctic exploration for 2 decades. His leadership, his emphasis on the welfare of his men, and his remarkable ability to survive and bring his men home from desperate situations had made him a legend. The quest expedition continued under the command of Frank Wild, Shackleton's longtime companion, but without Shackleton's leadership, it accomplished little and returned to England later in 1922. The late 1920s saw the beginning of the use of aircraft in Antarctic exploration. We mentioned earlier Hubert Wilkins and Carl Ben Ilsen's flight over the Antarctic Peninsula in November 1928. This was followed by Richard Byrd's flight over the South Pole in November 1929. These flights demonstrated that aircraft could dramatically increase the speed of Antarctic exploration. What had taken Scott months to accomplish on foot, Byrd achieved in 19 hours. However, early Antarctic aviation was extremely dangerous. Aircraft of the 1920s and early 1930s were not designed for polar conditions. Engines could freeze, instruments could fail, and there were no electronic navigation aids. Pilots had to navigate by dead reckoning and occasional sun sights. Forced landings on the ice were often fatal, as rescue might take weeks or months if it came at all. Despite these dangers, aviation transformed Antarctic exploration. Aerial photography allowed mapmakers to chart vast areas quickly. Scientific instruments could be carried over regions that would take weeks to reach on foot. Weather reconnaissance could provide advance warning of storms. By the 1930s, no major Antarctic expedition was complete without aircraft. The American explorer Lincoln Ellsworth made several important flights over Antarctica in the mid-1930s. In November and December 1935, Ellsworth and pilot Herbert Hollick Kenyon made the first trans-Antarctic flight, flying from the Antarctic Peninsula across to the Ross Ice Shelf. The flight covered 2,300 miles and took several weeks, as they had to make several landings due to weather and mechanical problems. They were eventually rescued by a British, Australian, New Zealand expedition. The Norwegian, British, Swedish Antarctic expedition of 1949 to 1952 was one of the first major post-World War II expeditions. This international collaboration was a precursor to the kind of cooperative scientific work that would characterize later Antarctic research. The expedition established a base in Dronning Maudland and conducted geological, glaciological, and meteorological research. They used aircraft, tracked vehicles, and traditional dog sledges, reflecting the transitional nature of Antarctic exploration at the time. The 1950s were a pivotal decade for Antarctic exploration and research. The decision to hold the International Geophysical Year from July 1957 to December 1958 focused international attention on Antarctica. The IGY was a coordinated effort by scientists from 67 countries to study Earth's geophysical phenomena. Antarctica was a major focus because of its importance to global climate and because much of the continent remained unexplored. During the IGY, 12 nations established research stations across Antarctica. The United States established several stations, including one at the South Pole. the Soviet Union established stations in the interior of East Antarctica, including Vostok Station, which would later become famous for the deep ice core drilling conducted there. Britain, France, Australia, New Zealand, Argentina, Chile, Japan, Belgium, Norway, and South Africa also participated. The IGY marked a fundamental shift in the purpose of Antarctic activities. While exploration and adventure had motivated earlier expeditions, the IGY was focused on science. The research conducted during these 18 months laid the groundwork for much of our modern understanding of Antarctica. Studies of the ice sheet, the atmosphere, the aurora, cosmic rays, and geomagnetism all contributed to scientific knowledge. One of the most significant scientific findings from the IGY period was the confirmation that Antarctica is a single continent covered by a massive ice sheet rather than an archipelago of islands. Seismic soundings and gravity measurements showed that beneath the ice lies a continuous landmass, though parts of it are below sea level. This finding resolved a long-standing question about the nature of Antarctica. The success of the IGY led directly to the negotiation of the Antarctic Treaty. The 12 nations that participated in the IGY realized that Antarctica was too valuable scientifically and too fragile environmentally to become a site of military or territorial conflict. The treaty they negotiated preserved Antarctica for peaceful purposes and scientific cooperation. This was a remarkable achievement, coming as it did during the height of the Cold War. The Antarctic Treaty, signed in Washington, D.C. in December 1959, is one of the most successful international agreements ever negotiated. For over 60 years, it has prevented conflict in Antarctica and fostered international scientific cooperation. The original 12 signatories have been joined by many other nations. The treaty has been supplemented by additional protocols addressing environmental protection, conservation of marine resources, and other issues. The 1960s and 70s saw a massive expansion of Antarctic research. Permanent stations were established at various locations around the continent. These stations varied greatly in size, from small, summer-only facilities housing a handful of people to large year-round stations with populations of 100 or more during summer. The largest station, McMurdo Station, operated by the United States, became a small town with dormitories, laboratories, vehicle maintenance facilities, a power plant, and even a harbour where supply ships could dock. Life at these research stations developed its own culture and traditions. The isolation, extreme environment, and shared purpose created tight-knit communities. People who wintered over, staying through the 6 months of darkness and cold, formed particularly strong bonds. There were traditions like the midwinter celebration on June 21st, the darkest day of the year, when stations would have parties and exchange greetings with other stations via radio. The construction and maintenance of these stations presented enormous engineering challenges. Buildings had to be designed to withstand hurricane-force winds and extreme cold. They had to be heated throughout the year, requiring reliable power generation and large quantities of fuel. Water had to be produced by melting snow or ice. Waste disposal was a significant problem, as burial in the ice was not environmentally acceptable and everything had to be removed from the continent. Some stations were built on stilts or skis to prevent them from being buried by drifting snow. Others were built underground or under the snow for insulation. The Amundsen Scott's South Pole Station has been rebuilt several times, with each iteration incorporating lessons learned from the previous version. The current station, which opened in 2008, is an elevated structure that can be raised as snow accumulates beneath it. Research during this period covered an ever-widening range of topics. Glaciologists studied how ice flows and how the ice sheet responds to changes in temperature and snowfall. Climatologists used the information preserved in ice cores to reconstruct past climates. Biologists studied how organisms survive in extreme cold, from bacteria to fish to seals and penguins. Geologists mapped the rocks beneath the ice and studied the formation of Antarctica as a continent. One area of research that gained increasing attention from the 1970s onward was the role of Antarctica in the global climate system. Scientists realized that the Antarctic ice sheet, ocean, and atmosphere all play crucial roles in regulating Earth's climate. The cold water that sinks around Antarctica drives the global ocean circulation, carrying oxygen to the deep ocean and moderating temperatures around the world. The ice sheet reflects sunlight back into space, helping to cool the planet. The discovery of the Antarctic ozone hole in 1985 was a landmark moment in environmental science. British Antarctic Survey scientists Joseph Farman, Brian Gardiner, and Jonathan Shanklin noticed that ozone levels over Antarctica dropped dramatically each spring. This was a shocking discovery. The ozone layer protects Earth's surface from harmful ultraviolet radiation, and its depletion could have serious consequences for human health and ecosystems. Further research showed that the ozone hole was caused by chlorofluorocarbons, chemicals used in refrigerators, air conditioners, and aerosol sprays. These chemicals are stable in the lower atmosphere, but break down in the stratosphere, releasing chlorine atoms that destroy ozone. The extreme cold of the Antarctic stratosphere during winter creates conditions that accelerate this destruction, leading to the formation of the ozone hole each spring. The discovery of the ozone hole led to rapid international action. The Montreal Protocol, signed in September 1987, committed nations to phasing out the production of ozone-depleting substances. This agreement has been remarkably successful. Production of CFCs has virtually ceased, and measurements show that the ozone hole is slowly beginning to recover. It is expected to return to pre-1980 levels by around 2070. The ozone hole discovery demonstrated several important points. It showed that human activities could have global environmental impacts, even in remote regions like Antarctica. It showed that international cooperation could address global environmental problems, and it showed the value of long-term scientific monitoring. The ozone hole was discovered because scientists had been measuring ozone levels over Antarctica for decades, providing the baseline data needed to detect the change. The study of climate change has become increasingly central to Antarctic research in recent decades. Ice cores drilled from the Antarctic ice sheet provide a detailed record of past climates. The longest ice core, drilled at Dome C in East Antarctica, reaches back 800,000 years. Analysis of the air bubbles trapped in this ice shows that carbon dioxide levels are now higher than at any time in that 800,000 year period. These ice cores have revealed that Earth's climate has alternated between ice ages and warmer interglacial periods, driven primarily by changes in Earth's orbit and tilt. They have also shown that carbon dioxide levels and temperature are closely linked. When carbon dioxide levels are high, temperatures are high, and vice versa. This has important implications for understanding current climate change, which is being driven by human emissions of carbon dioxide from burning fossil fuels. Antarctic research has also contributed to our understanding of how quickly climate can change. Ice core records show that in the past, temperatures have sometimes changed very rapidly, with shifts of several degrees occurring within a few decades. This challenges the earlier view that climate change is always gradual. It suggests that the climate system can have tipping points where small changes trigger rapid and dramatic shifts. The Antarctic Peninsula, the northernmost part of Antarctica, has warmed faster than almost any other place on Earth over the past 50 years. Temperatures in this region have increased by about 3 degrees Celsius since 1950. This warming has had visible impacts. Glaciers are retreating, ice shelves are collapsing, and the distribution of wildlife is changing. Some penguin species that depend on sea ice are declining, while others are expanding their range southward. The collapse of ice shelves on the Antarctic Peninsula has been particularly dramatic. Ice shelves are thick, floating platforms of ice that form where glaciers flow into the ocean. They act like buttresses, holding back the glaciers behind them. When an ice shelf collapses, the glaciers can flow faster into the ocean, contributing to sea level rise. In 1995, the Larsen A ice shelf collapsed. In 2002, the Larsen B ice shelf, which had been stable for at least 10,000 years, disintegrated in just 35 days. Satellite images showed the ice shelf breaking into thousands of icebergs. The collapse of these ice shelves has allowed the glaciers behind them to flow faster, contributing to sea level rise. While the Antarctic Peninsula has warmed dramatically, other parts of Antarctica have shown less clear trends. East Antarctica, which contains most of Antarctica's ice, has not warmed as much. In some areas, temperatures may have even cooled slightly. This regional variation is due to complex interactions between the atmosphere, ocean, and ice, which scientists are still working to understand. One area of active research is the behavior of West Antarctica, particularly the glaciers that flow into the Amundsen Sea. These glaciers are of concern because much of West Antarctica rests on bedrock that is below sea level. This makes it potentially unstable. If warm ocean water flows underneath the ice shelves that fringe the coast, it can melt the ice from below, causing the ice shelves to thin and weaken. Observations from satellites and field studies have shown that some West Antarctic glaciers are indeed thinning and accelerating. The Pine Island Glacier and Thwaites Glacier are of particular concern. Thwaites Glacier is sometimes called the Doomsday Glacier because if it were to collapse completely, it could raise global sea levels by over 2 feet. Moreover, its collapse could destabilize other glaciers in West Antarctica, leading to much greater sea level rise. Understanding the future behavior of Antarctic ice is one of the most important challenges in climate science. If the Antarctic ice sheet loses a significant amount of mass, the consequences for coastal communities around the world would be severe. Cities from Miami to Shanghai to Mumbai are vulnerable to sea level rise. Small island nations could become uninhabitable. Trillions of dollars of infrastructure could be threatened. Current projections for future sea level rise vary widely depending on how much greenhouse gas we emit and how the Antarctic ice sheet responds. Under low emission scenarios, where the world rapidly reduces its use of fossil fuels, Antarctic contribution to sea level rise might be relatively modest. Under high emission scenarios, where fossil fuel use continues to increase, the Antarctic contribution could be measured in feet by 2100 and could continue to rise for centuries thereafter. The uncertainty in these projections reflects gaps in our understanding of ice sheet physics. While we understand the basic principles of how ice flows and melts, the details are complex. Ice sheets are enormous, and processes occurring at the scale of individual cracks and channels can affect the behavior of the entire sheet. Improving our predictions requires both better observations and better computer models. To improve observations, scientists are deploying an array of instruments across Antarctica. Satellites measure the height of the ice surface, allowing scientists to detect whether the ice sheet is growing or shrinking. GPS stations measure the movement of the bedrock, which can indicate changes in the weight of the ice above. Seismometers detect earthquakes caused by ice movement. Automated weather stations record temperature, wind, and snow accumulation. Scientists also conduct field studies, traveling to remote parts of Antarctica to make detailed measurements. These expeditions can last for weeks or months and involve camping on the ice in extreme conditions. Researchers drill ice cores, measure ice thickness with radar, install instruments, and collect samples. Despite all our technology, there is still no substitute for scientists actually going to Antarctica and making measurements on the ground. One of the most ambitious scientific programs in Antarctica has been the drilling of ice cores. Ice core drilling requires specialized equipment and can take several years to complete. The drill must penetrate through ice that can be several miles thick, retrieve intact core samples, and operate reliably in temperatures far below zero. The European project for ice coring in Antarctica, EPICA, drilled the 800,000-year ice core mentioned earlier. This was an international collaboration involving scientists from 10 European nations. The drilling took several years, with teams working during the brief Antarctic summer when conditions allow. The core was divided into sections and distributed to laboratories around the world for analysis. Analysis of ice cores is a painstaking process. Scientists measure the ratio of different isotopes of oxygen and hydrogen in the ice, which provides information about past temperatures. They analyze the air bubbles trapped in the ice to determine the composition of the atmosphere. They measure the concentration of dust and chemicals in the ice, which provides information about volcanic eruptions, forest fires, and wind patterns. Each layer of ice is like a page in a book, recording the environmental conditions at the time the snow fell. Beyond climate research, Antarctic science encompasses many other fields. Marine biologists study the ecosystems of the Southern Ocean, which are among the most productive in the world. The cold, nutrient-rich waters support vast populations of krill, which in turn support fish, seals, whales, and birds. Understanding these ecosystems is important for managing fisheries and conserving species. Antarctic fish have evolved remarkable adaptations to survive in water that is cold enough to freeze most fish. Many species produce antifreeze proteins that prevent ice crystals from forming in their bodies. Some species have no red blood cells, which would thicken in the cold, instead relying on oxygen dissolved directly in their blood plasma. These adaptations are of interest not only to biologists, but also to medical researchers studying how to preserve organs for transplantation. The study of penguins has been a major focus of Antarctic biological research. Penguins are uniquely adapted to the Antarctic environment, with waterproof feathers, layers of insulating fat, and behavioral adaptations that allow them to survive extreme cold. Different species occupy different ecological niches. Emperor penguins breed on sea ice in the middle of winter. Adelie penguins nest on ice-free rocky shores. King penguins, which are subantarctic rather than truly Antarctic, have a complex breeding cycle that takes over a year to complete. Long-term studies of penguin populations have provided valuable information about Antarctic ecosystems and climate change. By banding individual birds and monitoring breeding success over many years, scientists can detect changes in population size and breeding patterns. Some penguin populations are declining, possibly due to changes in sea ice, ocean temperature, or food availability. Other populations are stable or increasing. Understanding these patterns helps scientists predict how Antarctic species will respond to future environmental changes. Seal research is another important field. Antarctic seals include Weddell seals, Crabiator seals, leopard seals, and Ross seals, each with different behaviours and ecological roles. Weddell seals are of particular interest because they breed far south and can dive to depths of over 2,000 feet, remaining underwater for over an hour. Scientists attach instruments to seals to track their movements and diving behaviour, providing information about both the seals themselves and the oceanographic conditions they encounter. Astronomy is a somewhat surprising but significant field of Antarctic research. The Antarctic Plateau, particularly the high interior region around Dome A and Dome F, is one of the best places on Earth for astronomical observations. The air is extremely dry and stable, there is no light pollution, and during the polar winter, observations can continue for months without interruption from daylight. Several astronomical observatories have been established in Antarctica. The South Pole Telescope conducts observations of the cosmic microwave background, the afterglow of the Big Bang. These observations help cosmologists understand the early universe and the nature of dark matter and dark energy. Other telescopes search for exoplanets, study nearby galaxies, and observe high-energy phenomena like gamma-ray bursts. The IceCube Neutrino Observatory at the South Pole is a unique scientific instrument. It consists of over 5,000 light sensors buried deep in the ice, arranged in a cubic kilometre array. The observatory detects neutrinos, subatomic particles that can pass through most matter without interacting. Most neutrinos detected by IceCube come from cosmic rays hitting Earth's atmosphere, but occasionally the observatory detects neutrinos from distant astronomical sources, providing information about some of the most violent events in the universe. Medical research in Antarctica has contributed to our understanding of how the human body adapts to extreme environments. Studies of people working in Antarctica have examined the effects of cold, isolation, altered light-dark cycles, and low humidity on physical and mental health. These studies have practical applications for improving the health and safety of people working in Antarctica, but they also have broader applications to other extreme environments, including spaceflight. The psychological challenges of Antarctic work are significant. During the winter, station personnel can go months without seeing the sun. They are confined to a small area with the same small group of people. Communication with the outside world, while much better than in the past, is still limited. These conditions can lead to mood changes, sleep disturbances, and interpersonal conflicts. NASA has supported research at Antarctic stations because the conditions are in some ways similar to what astronauts would experience on a long-duration space mission, such as a trip to Mars. Both involve isolation, confinement, environmental extremes, and dependence on life support systems. Lessons learned from Antarctic research about crew selection, psychological support, and conflict resolution have informed NASA's planning for future deep space missions. Antarctic stations have also served as testbeds for renewable energy systems and other technologies. The extreme conditions make for a demanding test environment. If a technology works in Antarctica, it will likely work anywhere. Solar panels, wind turbines, and energy storage systems have all been tested in Antarctica. While fossil fuels still provide most of the energy at Antarctic stations, there is increasing interest in renewable energy to reduce environmental impact and logistical costs. The question of environmental protection in Antarctica has become increasingly important. Early expeditions left behind equipment, supplies, and waste, thinking nothing of it. The pristine nature of Antarctica means that waste degrades very slowly, if at all. Abandoned buildings, fuel drums, and other debris from old expeditions can still be found scattered across the continent. The Protocol on Environmental Protection to the Antarctic Treaty, which came into force in 1998, requires that all waste be removed from Antarctica unless it can be safely incinerated or otherwise disposed of on site. This has greatly increased the cost and complexity of Antarctic operations, but has helped protect the Antarctic environment. Modern expeditions must carefully plan waste management, including sewage, trash, and hazardous materials. There are ongoing debates about how to balance scientific research, environmental protection, and other uses of Antarctica. Should tourism be allowed? And if so, how should it be regulated? Should bioprospecting, the search for organisms or molecules that could have commercial value, be permitted? How should historic sites from early expeditions be preserved? These questions are addressed through the Antarctic Treaty System, which brings together the treaty parties to discuss and develop policies. Historic preservation in Antarctica presents unique challenges. The cold, dry climate preserves artifacts remarkably well. Huts built by Scott and Shackleton over a century ago still stand, filled with the supplies and equipment they left behind. Tins of food, clothing, scientific instruments, and personal items remain much as they were when the expeditions departed. These sites are time capsules that provide a tangible connection to the heroic age of exploration. Conservation of these historic sites requires specialized expertise. The wood buildings are fragile and require careful maintenance. Items inside must be catalogued and preserved. Some artifacts have been removed to museums for conservation and display, but many remain in situ. The Antarctic Heritage Trust and other organizations work to preserve these sites for future generations. Visiting these historic huts is a profound experience. Standing in the same small room where Scott and his men lived through the Antarctic winter seeing the table where they ate their meals, the bunks where they slept, and the scientific equipment they used, brings history to life in a way that no book or photograph can match. These sites remind us of the hardships the early explorers endured and the spirit of adventure and scientific curiosity that drove them. The logistics of supporting modern Antarctic operations are staggering. Every year, dozens of cargo ships and aircraft transport thousands of tons of supplies to the continent. These supplies include food, fuel, scientific equipment, building materials, spare parts, and everything else needed to keep research stations operating. The main supply season runs from October to March, when ice conditions allow ships to approach the coast. The United States Antarctic Program operates a fleet of transport aircraft that fly between Christchurch, New Zealand, and McMurdo Station. These flights, operated by the New York Air National Guard and civilian contractors, carry hundreds of passengers and tons of cargo each year. The flight takes about 8 hours and crosses some of the most remote and inhospitable ocean on Earth. Weather conditions can change rapidly, and flights are sometimes forced to turn back if conditions at McMurdo deteriorate. Other nations have their own logistics systems. Australia operates the research and supply vessel Aurora Australis. Russia maintains ice-capable ships that supply its several Antarctic stations. China has invested heavily in Antarctic logistics, building a new icebreaker and expanding its presence on the continent. The logistical challenge of operating in Antarctica drives innovation in areas such as cold weather engineering, remote power systems, and satellite communications. Communication from Antarctica has improved dramatically over the decades. In the early 20th century, expeditions were completely isolated once they left the last port of call. There were no radios or other means of communication with the outside world. If something went wrong, the expedition was on its own. The first radio transmissions from Antarctica were made in the 1920s. By the 1950s, radio communication was routine, though still dependent on atmospheric conditions. Today, satellite communications provide reliable internet and phone service to even the most remote Antarctic stations. Researchers can email their families, video conference with colleagues, and access online databases. This connectivity has transformed the experience of working in Antarctica. While physical isolation remains, the psychological isolation is much less than it once was. However, satellite bandwidth is limited and expensive, so usage is often rationed. The International Association of Antarctica Tour Operators, IAATO, was established in 1991 to promote safe and environmentally responsible tourism in Antarctica. Tourism has grown rapidly in recent decades. In the 1991 to 1992 season, about 6,500 tourists visited Antarctica. By the 2018 to 2019 season, this number had grown to over 56,000. Most Antarctic tourists visit aboard cruise ships that tour the Antarctic Peninsula. These cruises typically last 1 to 3 weeks and include landings at various sites where tourists can observe penguins, seals, and historic sites. The ships range from small expedition vessels carrying fewer than 100 passengers to large cruise ships carrying several hundred. Larger ships face restrictions on how many passengers can go ashore at once. Tourism brings both benefits and concerns. It generates public interest in Antarctica and environmental conservation. Many tourists return home as advocates for Antarctic protection. However, tourism also brings risks. Fuel spills from ships could devastate local ecosystems. Disturbing wildlife, even unintentionally, can affect breeding success. Introducing non-native species, even microorganisms, could upset fragile Antarctic ecosystems. IAATO members follow strict guidelines to minimize environmental impact. Tourists are briefed on proper behavior before going ashore. They must maintain minimum distances from wildlife, stay on designated paths, and avoid disturbing historic sites. Waste management aboard ships is carefully controlled. Despite these precautions, some environmental scientists worry that the growth of tourism could eventually overwhelm these protective measures. A small number of tourists go beyond cruise ship visits to undertake more ambitious Antarctic adventures. Some fly to the South Pole for a brief visit. Others undertake skiing expeditions across the ice. These activities are much more expensive than cruise ship tourism and accessible to only a few. They raise additional concerns about the commercialization of Antarctica and whether private adventure tourism is compatible with the Antarctic Treaty's designation of Antarctica as a natural reserve devoted to peace and science. The question of sovereignty in Antarctica remains unresolved. 7 nations maintain territorial claims, but these claims are not universally recognized and are frozen under the Antarctic Treaty. The treaty system has worked well for over 60 years, but it is not guaranteed to last forever. As resources become scarcer elsewhere in the world, pressure to exploit Antarctic resources could increase. The treaty currently prohibits all mineral resource activities other than scientific research. However, this prohibition could theoretically be modified if all the Antarctic Treaty consultative parties agreed. So far, there has been no serious movement to change this, but the possibility remains. Some environmental groups advocate for making Antarctica a world park, permanently protected from any commercial exploitation. This proposal has not gained sufficient support to be implemented. Another potential future challenge is the use of Antarctica as a base for space-related activities. The dry, stable atmosphere and remote location make parts of Antarctica ideal for certain types of astronomical observations. Some have proposed building larger telescopes or even using Antarctica as a launch site for certain types of space missions. Such activities would need to be carefully evaluated against the environmental protection provisions of the treaty. Climate change is perhaps the greatest long-term challenge facing Antarctica. The changes already observed, particularly on the Antarctic Peninsula, are just the beginning. If global temperatures continue to rise, the impacts on Antarctica will intensify. More ice will melt, contributing to sea level rise. Ecosystems will be disrupted. Weather patterns could change. The Southern Ocean, which plays a crucial role in global ocean circulation and climate, could be fundamentally altered. These potential changes make Antarctic research more important than ever. Understanding how Antarctica is changing and what the consequences might be is crucial for planning humanity's response to climate change. Antarctic research contributes to climate models that inform policy decisions. The data collected in Antarctica is used by decision makers around the world as they grapple with the challenge of reducing greenhouse gas emissions and adapting to a changing climate. Looking to the future, Antarctica will likely see continued growth in scientific research, continued development of technology and infrastructure, and continued challenges in balancing research, conservation, and other human activities. The continent will remain a focus of international cooperation, a laboratory for studying Earth's climate and ecosystems, and a place that challenges and inspires those who visit. The story of Antarctic exploration, from the first sightings in 1820 to the sophisticated science programs of today, is a story of human curiosity and determination. Early explorers faced unimaginable hardships with primitive equipment and limited knowledge. Modern researchers face different but still significant challenges, working in one of the harshest environments on Earth to answer fundamental questions about our planet. The human drama of Antarctic exploration, the stories of courage and tragedy, survival and loss, continue to resonate because they reveal something fundamental about human nature. We are driven to explore, to push boundaries, to seek knowledge even at great personal cost. Antarctica has been the stage for some of humanity's most remarkable achievements and most tragic failures. These stories remind us of both our capabilities and our limitations. As we reflect on over 2 centuries of Antarctic exploration and research, we can appreciate how far we have come. What was once a mysterious, unknown land at the end of the Earth is now a continent that we understand in considerable detail, even as many mysteries remain. We have learned an enormous amount about Antarctica's ice, oceans, atmosphere, and life. We have learned about Earth's climate history and about the changes now occurring. Yet Antarctica retains its power to inspire wonder. The sheer scale of the ice sheet, the beauty of the landscape, the abundance of wildlife in the surrounding oceans, and the extremes of the environment all combine to create a place like nowhere else on Earth. Those who visit Antarctica, whether as researchers, support staff, or tourists, almost universally describe it as a transformative experience. Thank you for joining us on this exploration of Antarctic expedition history. May these stories of ice and courage, of tragedy and triumph, of human limitation and human achievement accompany you gently into peaceful rest. Sleep well, knowing that while you sleep, researchers in Antarctica are awake, working through the polar day or polar night, continuing the great tradition of Antarctic exploration and science that stretches back over 200 years.